going to start by actually looking at that benchmarking report. We're doing this every year. We have quite a bit of reach, and so we've been able to get against a good amount of respondents here. Now, the specific thing that we're always asking is how does the setup of your organization actually level or benchmark against the rest of the market? The impression that I always have, or that I specifically had when I was embedded in teams, was that I'm working in my setup. How do I compare to others? Are we doing well? Are we not doing well? It's sort of a constant problem in engineering. It's it's hard to measure. It's difficult to understand where you stand. So for me, we really started gathering these data points because we didn't trust any other data points, and there was no thorough measurement of these things. And I find this year's result quite remarkable again. That's it, DevOps Benchmarking Study 2023. I think we'll share that later. Okay, we'll go to exactly 2 agenda items today. The findings, we're going to review them, and then I want to spend a good amount of time on how to act on them. And again, please feel free to ask questions whenever you have them. Okay, as always, we have asked questions, and you could get results based on those questions. If you actually map them, so you could get again 0 to 100 points, and we are seeing this the normal, the usual, we call it DevOps mountain of tiers, where you can see that we have the majority of teams still oscillating somewhere in the middle. And then you have a long tail. The data, and we should actually do A/B data. The data has improved slightly, but we still see this chunk of respondents that are not able to make the most out of DevOps. Now, let's actually go into a little bit of detail. And first, we are always asking, what are the sort of environments you're running? And we are, as you might be familiar, dissecting the respondents into top performers, high performers, medium performers, low performers. And it's always interesting to see. I'm basically primarily looking at top performers versus low performers, and you can see the trend line fairly well. So the first thing is, where does the infrastructure run? You can see public cloud is the dominant element here for the top performers, and then the low performers are still predominantly on-prem. That's a little bit unfair and misleading. If you are a large bank, then it takes longer to get your estate shipped into the public cloud, and you have governance things. So calling that low performing is unfair. It's significantly more complex to move these estates. There are these rumors about, the cloud is expensive, and you have Basecamp and other people shouting, let's move back to on-prem. That's a very noble dream, but in reality, still not something that we're seeing. There's no trend that indicates anything in that direction. The contrary actually holds true. The estates are still going predominantly into the public clouds. We do see pressure on the pricing structure of the public cloud vendors. So there is a lot more focus actually on the CIO level on reducing prices, especially in the enterprise. Good. Now, it's also very apparent that containerization is the big thing. If you look at top performers, 80% respond with most services are containerized, and in the lower performing buckets, you can still see that this is not quite the case, but you can also see that medium and high performers are significantly catching up. The rate of containerization is quite stunning, and Kubernetes is the dominant orchestrator. While in the last years we still had an astoundingly high degree of Docker Swarm, for instance, that is basically gone. There is the usual question with serverless, is this the future? The absolute numbers of serverless consumption are still going up. I don't have the exact numbers, but if you look at the relative numbers, so the entire market is still, cloud market is still increasing. The relative numbers of serverless are actually going down relative to the general uptake, and we're also seeing this on a daily basis. The actual estates here are. It looks like serverless is not actually the direction of choice. It's specifically focused on event processing, batch processing, and these things. The dominant method remains Kubernetes. There is a little bit of convergence with Knative, Cloud Run, and the likes, but especially Lambda, and a great way of understanding this is to look at a fourth-ranked revenue list of services on Amazon Web Services, and I think the Lambda is currently on position 34. Right. So this is basically the estate that we're confronted with. Let's look a little bit at the DORA metrics. We still have drastic difference between the top performers and the low performers that are shipping in minutes versus months. Again, here, slightly misleading because you can have different governance situations. If you are able to go to pre-prod really fast, but then production needs a sign-off, and then sign-off happens in ServiceNow across 3 different time zones, then these things are simply not then the numbers are unfair. I'm looking at the comments here. What are the criteria for performance here, and what are respondents? What makes a respondent a top performer? Yeah, great questions. So we have a whole section on this in the benchmarking report. So I'm not going to cover that much. But some of them are, the obvious things. Shipping faster is probably better than shipping slower. And those are the majority ranking criteria that are used here to identify top performance. So that's specifically looking at DORA metrics. And are these things statistically significant? Those are numbers, I think, at 2,000 respondents. There's a certain bias in there. I mean, let's be clear, because the users are they're worldwide, but they have a bias towards the United States, and if I recall, they have a bias for Twitter users. So we have to, as always, be careful with the interpretation of those numbers. But in relative terms, I would say they are fairly representative. Now, then let's continue here. Deployment frequency, the same thing holds true. Same comments that I just made apply here as well. There is a large difference in the deployment frequency and how often you deploy. But I think in general, it's fair to say that the majority of the general CI/CD setups are improving if you look at year-on-year performance here. The mean time to recovery elements are still pretty high. So if you look at low performers and almost 25% that meet 1 day to up to 1 week at the current load that we are seeing on these systems, that is still quite significant. Change failure rate, that's actually something that if you look at year-on-year has dropped significantly. We had, if you look at the data 2 years ago in the low performer buckets, and then here to the question of statistical significance, again, this is more like on a diff to diff basis is what's actually interesting, because we're applying the same structure and the same the same measurement structure every year, right? So the relative development is interesting. That's definitely something that we I should have included here. But if you look at 2 years ago, the number of low performers that had a change failure rate of 31 to 45% was 3 times that. So those data points are definitely going down. Configuration management is an element that I find very important and very interesting. And I think now we're actually getting into the key things that one can improve on their setup. Obvious things like storing app configs in a version control system. We can see that still 32% of low performers are not applying this, but and this is actually great to see how the data is cleaning up and how this is actually converging to a industry-wide safe standard here, because only 2 years ago the data for low performers was invert, so it was 70% on people that actually did not have that in a version control system. Now, the application configurations and infrastructure provisioning, this here is an important element, and this is where you still see low performers having that significantly higher rate of application configurations that are completely separated from the provisioning of infrastructure. And the top performers, 72% configurations, are handled the same way as infrastructure dependencies for an application. And that's something that we are going to look at in a second on key recommendations on what you can support. So I am an increasingly big fan of adding a layer that describes the abstract relationship of application configurations and infrastructure configurations. And I am a wild fan, I'm outing myself, on dynamically creating the final executable configurations rather than taking existing configurations and fiddling around. And this will sound a little blurry, but I'm going to explain what that means in just a second. This one, another good one, which counts into the same bucket, environment-specific configurations and environment-agnostic configurations. How do you keep them apart? And we can see that in top-performing organizations, over 80% strictly separate environment-specific configurations from environment-agnostic configurations, and that is almost inverse for the low performers. What does that mean? It means that I have a set of configurations that describe the relationship of a service element and dependent resources in an entirely environment agnostic way. And I'm generating the actual environment specific elements of the configs just in time with the deployment again. So again, following that approach of dynamic configuration management. Why does that make sense? It makes sense because it decreases the total maintainable surface area for configurations in general. And it allows for, and this is a little bit of an icy terrain, the separation of concern between the application developers and the platform engineering team, the operation teams, and it allows us to let these teams focus, maintain their areas, and combine configs, baseline configs, and environment agnostic configs from both teams. And that is something that we are going to look at in more detail later. Yes, we are going to share those presentations. Now, here, this is another way, standardization across the organization. Standardization across the organization is always something that, especially in the early years of public cloud, if this is a little bit pathetic to say that because it's basically 5 years ago, but especially when the mainstream started to go public, we had a wild area of different things happening, and now we're seeing a significant increase in attempts to standardize on the application configuration level, making sure we have We work against baseline charts, making sure we're standardizing our infrastructure as code estate. All of these things have happened and do continue to happen. And that's something that we clearly did not see even 2 years ago. All right, the next element, and that's something that has been much talked about, is the degree of self-service. If I speak about self-service, I make that there is a wide array of opinions of what self-service means. Many of us in the platform engineering world have, when we spoke about self-service, we meant day one self-service, day zero self-service. I need a new environment, I need to spin something up. All of these things, I'm getting onboarded for the first time. If I speak about self-service, or what we're actually seeing work on the ground, is self-service across the entire lifecycle of the application. And that's a very, very important difference, because self-service that's focused on day zero does not provide, in my observation, there's no data on this, the necessary return on investment, because it is a very short period in the lifetime of both a workload, resource, or developer. And which is why we really need to see self-service holistic across the entire software development lifecycle. So let's look at this here. The thing that's somewhat clear is that developers that are in the top performing bucket can be self-served by developers. And that is probably less true for low performers. Again, here, not maybe unfair to use the word low performers. In compliance heavy environments, it is simply not possible to say, hey, why don't you customize the Terraform for your production cluster and you work in a bank in New York? That is just simply impossible. We're in a situation where in these teams, there is still very often a human that is reviewing the final files, and in those, self-service is only possible to a certain degree in this situation. Now, who on your team is able to deploy to dev and staging? We're also seeing a clear path that this is now almost everyone can do this autonomously. Some low performance, and those are again specifically the governance-heavy industries are struggling with that still. Now then, how do you provision infrastructure and managed services that applications depend on? That is vast majority now infrastructure as code, or built into pipelines, or still some, especially in the middle tiers here on the cloud consoles. And there we still see that operations still very operations heavy. On the governance heavy side. So to give you an example, what this means, very impressive numbers from a UK financial institution have 50 GCP projects today that create around 1,000 tickets to the operation team, is planning to scale to 500 GCP projects. And you can imagine if they now have to scale to 10,000 tickets, that's probably not a very good idea. So this is still something that we have to manage. In general, one thing holds true, and that is a metric that that we've not actually collected, but that I'm observing continuously. Again, this is an observational data point. The relationship between operations, full-time equivalents, and developers is way too high. In a well-run platform engineering setup, you have a relationship of operations people that serve full-time equivalent developers of 1 to 50, 1 to 80. We're seeing setups that are currently on 1 to 10, 1 to 15. That is something that is unmaintainable. So what we've basically not been able to do yet as an industry is detach the scaling of the application developer from the, and so we're scaling linear still with the operation teams. Now, who assigns resources such as databases and DNS storage to an application? That is, in the majority of cases of the top performers, done by developers based on golden paths. We're going to talk about this in a second, and it's still the majority of the other buckets on the ops team. It remains incredibly difficult for the entire industry to do a simple lookup what database depends on what service. We can see that the majority of estates are trying to solve this with GitOps. I'm not sure whether you have ever debugged a failed deployment across 50 microservices in a repository. That's not fun. That is definitely a problem that is in the current approach to configuration management not solved. Again, this is where I'm heavily advocating for dynamic configuration management, which makes that much simpler. How long does it take for your team to initially bootstrap a new application? Here we're making and deploy it. Here we're making good, that's going into the right direction. Here we see top performers are now at 50%. This is something that was at 27% a year ago. You know, you have service catalogs such as Backstage coming up to optimize this. Again, I believe, and I've made that very clear, and I've not only made friends with those comments, but I believe that we're here actually focusing on the wrong value drivers. I don't think spinning up a new microservice is what we should optimize on. We should optimize, and we're counting to this developer self-service element. This is counting into the this general sentiment that developer self-service should never be thought about the day one and day zero operation. Okay, so here key findings and how can we actually dissect that? And what I thought was stunning is that if you look at those data points, we can actually derive optimal designs for internal developer platforms. You know, if you just sort of to bring all of us up to speed, platform engineering is really the craftsmanship around building scalable golden paths, building platforms that allow for standardization by design. Standardization is here really the key element that then as a result reduces the maintainable surface area, introduces careful separation of concerns without restricting the individual user. And if we look at these key findings here of the report, we can actually derive a couple of design criteria, and that's what I want to go through, and that's actually my core recommendation, my core reading of the data. We have to get from the philosophy of DevOps and thinking about this in a certain way to the productized platform engineering approach. So what can we derive here? Number one, optimize for containers in Kubernetes. This is more or less a done deal. I'm aware that there's still elements on VM. There are some new serverless workloads. Fine. You have to focus on something. You have to focus on the lowest common denominator. I'm seeing many setups. Not a single one is able to really optimize the experience across all different estates. Then second, we need to standardize. And I can't say that enough. Standardization is driving returns. And standardization is a political enemy. You make yourself you can make yourself a lot of enemies if done poorly. But standardization and developing platforms and systems that drive standardization by design is absolutely vital. The next element is dynamic configuration management. We've seen this all over the data. High-performing teams have a clear separation between environment agnostic and environment specific elements of the configuration. They treat application and infrastructure configurations in combination. They are actually creating configurations by applying abstract environment agnostic elements against baseline configurations supplied by platform engineering groups. And as a combination of those, they're actually creating configurations just in time with the deployment. And as a result of these elements, we are now getting self-service. Self-service is important because it reduces dependencies across teams. It is reducing silos across teams, and it's making it significantly easier to serve a larger amount of application developers at a higher quality and frequency with a steady base of operation teams. All right, so from that, we can actually also see that in the data very clearly that 93% of the top performers are now building or have built internal developer platforms. And there is this data by Gartner. 80% of platform engineering of organizations will have an internal developer platform by 2026. Very specific. I have no idea how they came up with 2026, but we can clearly see that top performers with 93% are now building those platforms, and that tells us something. We've seen these teams being the front runners over the last years. So platform engineering is the next thing. The question is, Forbes put a great piece out 2 days ago. How can platform engineering move beyond the buzzwords? What is an internal developer platform? What is a golden path? And I've been using these words for literally years now, but I've not been very concrete. And I want to get more concrete. That was the promise here. So what I want to show you now is the reference architecture that was developed and actually is packaged as code now by McKinsey's platform teams. We're showing this prior to the actual release of their white paper on the design of a modern internal developer platform that follows these the aforementioned criteria. And here we go. This is it. A simple diagram. So you're all a little sad now because it's yet another diagram, but I promise it's actually something that's pretty cool, because we've seen this rolled out at large scale now across hundreds and thousands of developers, and it is working very well, and it's something that's concrete. So what's the idea of this? The idea is to say, okay, what are the tool combinations that we are often seeing? How can we think about them? What is their job? And how can we basically build a default that works well together? Let me be very clear. The reality in almost every enterprise is that you have multi-CI, probably different infrastructure as code elements, different image registries. That's fine. That is sort of applicable for this as well. There are a good amount of different reference architectures actually rolling out. This one here is one for Amazon Web Services. The different logos, you can exchange them. Those are just proposals. You can use different workload specification, different version control, different CI pipeline, different orchestrator. That doesn't matter. Those are really just proposals here. But it's a certain way of interplay and a certain way of how requests actually run through the system A to D. I don't want to spend too much time on this because we're going to have a dedicated session hopefully together with you on Thursday, but very quickly here. So the idea is that we have, the McKinsey team has dissected this for better understanding into 5 different components, what they call planes. We have on top the developer control plane. Little bit misleading word here, because that is not only a control plane for developers, but obviously also used by the platform engineering team themselves. The developer control plane is the interaction, the interface between the user and the platform. It's important that this design is leaving interface choice. What does that mean? The individual user should be able to use an interface that she or he feels most comfortable with. We've seen several of the early platforms being very user interface heavy, and we've seen that this is great for some users, but limits adoptions for others. And so these designs are now optimized for primarily code-based interactions. So the user not having to leave the version control system, but also surfacing all information on a UI layer, namely a portal or service catalog, and having a single source of truth as code model, which in the modern enterprise, as we've seen in the data, is the predominant method and very important. Now, the different elements of the developer control plane vary by, or the jobs of the different planes vary by use case, if you want, where the portal is more an aggregation, documentation, and scaffolding element. The elements of the version control system, specifically the element of the workload specification, is serving that idea that we saw on the configuration element, which was specifically around how can we express the relationship of a workload and its dependent resources in an environment agnostic way. We've seen that the majority of high performers are actually applying that methodology. Workload specification, an example here is the open source project that I've also been working on, SCORE. So this is sort of a little bit shameless positioning here, but SCORE is a way for developers to say, hey, I have a workload, that's the name, I have a dependency on a database of the type Postgres and a DNS in an S3 bucket in an abstract way, right? And that's what I mean by differentiation between environment agnostic and environment specific elements of the configuration. Now, the predominant method of infrastructure as code is Terraform with, I mean, 9 out of 10 setups I'm looking into without having specific data are now on Terraform. Now, that's the developer control plane element. Then we have the integration and delivery plane. We have the CI pipeline, obviously, to build our stuff, the registry to store the images. Again, this platform is optimized for containerized workloads. Then we have something like a platform orchestrator, which is generating the configurations by taking the workload specification as the abstract request, taking the matching context, where are we deploying to, then looking at the defaults provided by the platform engineering team. If this developer deploys to staging and needs a Postgres, I want you to wire to that particular database and creates app and infrastructure configurations just in time with the deployment, which we then call dynamic configuration management. And then you have CD pipelines. I think this is a bad example. This is in 98% of cases Argo CD. And then we have, which then in combination makes the delivery plane level. And then we have the resource plane where the final resource comes. This here is using Amazon EKS, RDS for database, Route 53 and SQS. This is just sort of an example state. Everything that's terraformed can actually be consumed here. Then we have the monitoring and logging plane and security plane for secrets management with HashiCorp Vault. Yeah, so this is a proposal for a reference architecture on Amazon, one that we are seeing a lot of in terms of combinations. What I want to show now is actually that if you get the fundamental building blocks of this right, specifically from a configuration point of view, this dynamic creation, this increasing separation of concern. By doing this, we're basically adding opaque abstractions, if you want. So that approach of dynamic configuration management drives standardization by design. As a result of this, I am getting developer self-service across the entire lifecycle of an application. I'm going to explain what that means in a second. If I am dynamically creating the app and infrastructure configurations with every deployment, then I am basically treating every single deployment like day zero. This is as if I would scaffold a new service from a service catalog with every single Git push. And that is actually what allows the developer to say, well, in this deployment, I want to add an S3 bucket in general. Send that through your CI pipeline, and that platform will then actually make sure that the right S3 bucket is created or matched. And we're going to follow such a flow. And that flow, and now we can be very specific, that flow is what I mean if I am using the word golden path. All of this leads to an elimination of ticket ops, or at least a heavy decrease, because the developer can now say, I want this, and the default is matched. It leads to a reduction in config files. As a result, I have a lower surface area to maintain. I'm getting that idea of golden paths. I'm getting lower cognitive load. And ultimately, and that is the most important metric if you want to do anything around platform engineering, it slashes your lead time. And if you want to translate that to the C-level messaging, it actually reduces the time to market for new innovations. Right. Now, as a last thing, I want to actually explain that idea of dynamic configuration quickly, because that's clearly what we're centering that design around. And the idea here is that we have that abstract request from the developer, a workload specification, right? Again, you know, SCORE is the open source project that I was part of. You describe, hey, I have a workload. It depends on a database of type Postgres, S3, DNS, in an abstract way, right? We're not saying it depends on a particular database in an RDS instance. We're saying a database of type Postgres to remind ourselves we're keeping environment and agnostic and specific elements separated. Now, that workload specification, I have exactly one per service. It sits next to my workload source code in my version control system. And with every Git push, I'm basically sending that through the CI pipeline. It goes through the CI pipeline. The CI pipeline, now, you know, it depends, right? If I'm running it local, there's a SCORE compose to actually convert that into Docker compose. If I'm then sending that through my CI pipeline, it at some point hits an orchestrator. And the orchestrator reads this and responds with a RMCD execution pattern, which stands for read, match, create, deploy. It's reading that specification, the abstract request. It's matching the context. Oh, this is a deployment to an environment of type staging. It's then creating the app and infrastructure configurations by applying that abstract request to the baseline configs provided by the platform engineering team. And it's then actually creating the files and probably handing over to something like Argo to do the deployment, the sync, and the orchestration, or work in tandem with something like HashiCorp Terraform, or directly applying Terraform files. Right. And so if you want, what this actually gives us is an asynchronous love affair between platform engineering and application developers. And you know, the first thing by looking at this is you'll say, oh, now we're actually shielding developers too much. Is that a degree of abstraction that they actually don't want? Now, the good news is that we're not actually forcing them into this abstraction. We're giving them what we mean by golden path. The golden path always opens the door to leave the golden path, which is why we're calling it this way. And this is exactly what I want to actually follow through. Let's actually go through such a golden path. And we are using an incredibly simple example. We are just deploying to development. The service is already there. Everything is there. We're just doing git push to an environment of type development. We're taking as we discussed, the abstract workload specification is a part of the repository. We're taking that abstract thing and we're pushing it through the CI pipeline. It is hitting, we're getting a context. I'm deploying to an environment of type development. That's the matching criteria. It's then hitting the orchestrator, and the orchestrator is going read, match, create, deploy. It's reading this, it's matching, it's then creating the application configurations, and it's deploying. And we have, in this example, you know, a cluster configured, everything is up and running. You're looking at this and saying, so what? My CI pipeline can do that today. And that's absolutely correct. This is a very simple example. But what the CI pipeline can't do today is actually standardize with every single Git push, change the policies under the hood, add labels and annotations, change the latest version of Postgres, make sure that there are not 50 different versions of Postgres, but maybe only 3 or 4, and actually streamline these things and do that a synchronous handshake, a synchronous love affair between the different parties. Now, let's take another example, Golden Path 2. We are going to scenario 2. We want to create a new environment. This could also be scaffolding a service. And this is already giving us a feeling for, hey, what does it mean to do developer self-service across the entire lifecycle of an application? We are taking the exact same score file, no change here, same workload specification. The only thing that we're changing is that we're now deploying into a context of an environment equals ephemeral. We need an ephemeral environment. We do this by indicating this in the CI tag or by app ID or whatever matching criteria we want to use here. It hits the orchestrator, and I sort of want to make this clear. The orchestrator is something that is very often just built by the platform engineering team. We have, again, read, match, create, deploy. In this case, there is no Postgres, there is no S3 bucket, there is no DNS. So we are going to call the right infrastructure as code elements, maybe, to create all of these different things, and then create config files, inject the secrets, and off we go. The same thing holds true for production, low-hanging fruit. And now I want to walk you through what it means to go off the golden path. Right. Let's take an example. The developer needs a ArangoDB. ArangoDB is something that you never need until you need it. And by default, this is where usually a lot of platforms fail, and you would need to go to operations, or if operations are slow, developers are frustrated because they feel restricted. They can't go down to the Terraform level. It feels like you're taking context away from them, and that's deadly. You don't want to do that. So the beauty of this approach is that you can say, well, you can actually teach this system how to create a ArangoDB. If you have the necessary role-based access control, you can go under the hood, you can go down to the level, you can basically choose the level of abstraction that you feel comfortable with. You add a resource, you hit the orchestrator, it's doing read, match, create, deploy, it's giving you that ArangoDB. And the next time somebody needs ArangoDB and is in your context, well, then what you need is already there. And that's what we are also calling standardization by design. Before we wrap up, and I'm sure that I'm way over time, very sorry, and there are lots of questions. How does a portal fit in a service catalog? Well, that's something that you put on top. It is a pane of glass, a window into your platform. It is, and that's sort of a wide misconception. That's not your platform. It is one component of your platform. We've seen that in the reference architecture. And I'm, there are a good amount of offerings in that space now. Before, I'm taking lots of questions, but I am going to cover the architecture and architecting these things in a lot more detail on Thursday. Would love to see you there. And now let's actually see what questions we have. From Felix, the internal developer platform you're referring to seems all to be from cloud-based environments, backends. Do you have an experience with software on devices? Yeah, this is a great great question. To be completely just, please go ahead, Maria.
No, just one note, Kaspar. Thank you for being very passionate. But for the next questions, I think it would be good to read out the questions from beginning till the end, because people who will be watching later, they do not have these questions in front of them, and I can read them out for you.
That's, please.
Or, so the question from Felix, the internal developer platforms you're referring to seem all to be from cloud-based environment, backends. Do you have experience of similar platform for software on devices? They need releases which you need to test separately before you cannot use Amazon tools, or does the approach only work for the backend?
To be completely transparent, I am not aware of similar architectures for those types of environments, and I frankly do not have the experience. I don't think I can comment on this with you know, a legitimate standpoint.
Cool. Jeff is asking how they can get access to the underlying survey data. I'm not sure if we shared it somewhere in the road.
Yeah, that's a great question, Jeff. I completely with you. That should not be a problem. We can be in touch later on this.
Cool. How do you spell your shameless open source plug? I don't know.
So it's a score, like the musical score. score.dev is the GitHub repository.
Cool. How is Score different from Argo CD CRDs?
So I would say I'm not sure Argo CRDs are the right comparison here. The score is really a pretty high level relationship between, it's a specification. It is a relationship between a service and its dependent resources. And in itself, sort of worthless, needs to be translated. And then there are implementations, and these implementations are actually so, for instance, Score Compose, Score Helm, and take the abstract request and actually convert that into executable elements, Helm charts, for instance. CRDs, that's actually to put the resource through the Kubernetes API into a right state. Another project that I would take a look at is the name is Acorn, ACORN, and then vaguely in that direction is the OPA, open. Yeah, we're going to share a few options.
Cool. Question regarding architecture: is there a single source of truth in code, or is a source of truth in the orchestrator piece?
No, it's in code. Yeah. So that I think is very important. So not like the orchestrator layer, however designed, should not leave traces on the actual final result. So that should be 100% in code.
Cool. Like the question from Ricardo: if you were to start implementing such reference architecture, is there a recommended order to put all the pieces together, specifically as a proof of concept, starting small?
Yeah. So yeah, this is the thing that was so daunting. I know of endeavors that built the reference architecture that I showed you in 24 months, but a incredible cool thing that is not out yet, but McKinsey is open sourcing this packaged as code. So basically, you can throw that as an I think it's starting with Amazon. Throw this at an empty Amazon project and at the account credentials, and execute a Terraform, and everything you just saw there will set itself up. I think with the exception of the portal, but I'm not sure. On the multi-cloud question, that is also something that is in immediate development by them. Let's have we can actually show you these as an example. So this is the one on Amazon, this is the one on Google, this is the one on Azure, this is the one on OpenShift, and here is one on multi, and it's using Amazon and GCP as an example. And here you can actually see that then there's a discrimination by the cloud estates. So the elements are basically based on the matching context, the configurations are either created for estate A or estate B. Because they are dynamically created, that is absolutely possible. I do not know when this is available as code.
Kaspar, you're spoiling too much. the webinar on Thursday, I feel like. But next question, is it worth to rely on now in ChatGPT technology to produce code for infrastructure? Should we wait?
Yeah, that's a great question. Okay, this is something that I'm thinking of a lot. So the problem with ChatGPT, and you know, I'm bashing through all of the applications. I want to write like a longer piece on generative AI for platform engineering. The problem that we currently have is I would call it a self-driving car problem, right? So we are not at a point where we can write these systems and actually really rely on the outcome, especially in more complex estates. The result is a fairly significant dissection time, basically, to understand what the AI has put out. And that might sound simple, but if you really need to make sure that the result is, you know, even pre-prod great, because at some point you need to move into production, you're investing in like an incredible amount of time actually proofreading this. So much time that at least at all the tests that we've conducted, or that I've conducted, but to be fair, I've just played with that, I've not been able to even come close to like an actual hard impact. We wrote, as an example, auto generation for workload specifications, and these demos feel super impressive, but the results are just not reliable enough at this point.
Makes sense. Any points on setting up internal developer platform for on-prem?
Yeah, so if we're looking at this approach here with OpenShift, that, you know, that is very similar. There is no big difference, and definitely makes sense.
Score seems be very similar to Customize. What are the core differences between them?
Yeah, well, I mean, Customize has elements, but is not allowing for that dynamic creation, especially including the infrastructure components and elements. Customize is a way of, you know, trying to keep the charts small, if you want, but not about having that abstract element, especially encompassing app and infrastructure configurations, and then allowing for that dynamic creation. Score really only makes sense if you want dynamic creation of something based on rules that encompass both app and infrastructure configurations.
And I just posted a link for it's open source. Should the internal developer platform support two-way sync, where the actions performed in the UI layer translates to code, and the changes in infrastructure code also reflected in UI?
Yes, I mean, so I think the answer is every change in the user interface should always be reflected in code. Code, you know, has to be the single source of truth. You do not want to have elements in a specific system, especially not in a specific vendor system. Should the changes in code be reflected in the user interface is a non-trivial problem, because you have like a little bit of a state issue. And while code is very flexible, the UI might not be, and so the devil's in the detail there. Like wherever possible, yes, but that is not always possible.
Cool. Yeah, and guys, we'll share slides after the webinar on Thursday, so make sure you register, make sure you attend if you have any questions. And I guess we are taking the last question and we are on time. Kaspar was very passionate. I'll yell at him later for not following our timeline. But this may be related how you measure the DORA metrics in such reference architecture, either a tool or assistance by the orchestrator. This will be a way for orchestrator to show the benefits and progress of the architecture.
Mm-hmm. So the DORA metrics, that is really interesting. If you have an orchestrator element that creates configurations dynamically, then you have one element that allows you to measure all of these things. So for instance, there is a company in Australia called Legilica. We can share the link to them. And they have built a sort of like an analytics system for DORA metrics, but they are actually they have an integration with a platform orchestrator to actually pull that that information out and aggregate that to create those DORA metrics. So it's a single source of truth, right? And that's the great thing, and it allows you to. I mean, the reality. I mean, even in our engineering team, and I would say we're like not wildly large, and we're fairly, fairly standardized. We're like just to try to do we still have like a, I think a number of CI providers and pipelines. Some use Circle CI, some use GitHub Actions, and some use Jenkins or whatever. And so the beauty is that the orchestrator layer can actually consolidate all of those different elements, and because it's all of this is running through the orchestration element, it's much easier to backwards deduct the relevant metrics there. Cool. I hope this was helpful. I'm very excited to get feedback on those architectures from all of you. I've been pouring an incredible amount of time into them, and so reach out anytime, kaspar@untitled.com, or LinkedIn. LinkedIn probably getting too many messages, but like email is great. Twitter is often great, and so would love to hear from you. And I would. I'm looking forward to seeing you Thursday, hopefully.
Yeah, on Thursday. Thank you very much, Kaspar. And one person says, "Don't yell at you too much," but next time on Thursday we'll follow the agenda and have enough of time for Q&A. Hope everyone has a great rest of the day or just start of the day, and I'll very much see you that we'll see you on Thursday, and we'll send over slides and webinar replay tomorrow. So stay tuned. Thank you all.